welcome back. We're gonna start on module 11 on our surface water treatment rule. I know there's just a little bit of the plants you're actually using surface water. So we'll hit on some of these points in the module, things that I consider to be fairly important about it. When we look at why the rule was made, what are we trying to control, who's being monitored under it, or who has requirements under it. One of the important things is that we're obviously looking at microbial contaminants. And we've talked a little bit about the issues with crypto in Milwaukee, and especially that put a big spotlight on our surface water treatment. And so filtration rules came into effect, backwash rules, and a lot of other things that were really important for us to minimize that. So who's regulated by that? Well, surface water, and then GUIs also, groundwater under the influence of surface water. And how do we know if you're under the influence of surface water? Well, every time you get a big rain, when all your parameters jump all over the place, you start getting high turbidities, pH is fluctuating, alkalinities are changing and all, then you're probably under the influence. Most of those are alluvial systems that are in close proximity to especially rivers. GUIs are listed under the subpart H. The things that we're really looking at are microbials that are hard to disinfect. Most of it we get with chlorine, and we're pretty good with. Giardia, really hardy. Some of the viruses, so we have to look at what we call log reduction. This is a mathematical term. So we're looking at, for Giardia, we need a 3 log reduction and a 4 log. So we'll start getting our bin classifications and all. That's how we're figuring out what percentage reductions we need to have. And there's ways we can go in and do our profiles. One of the important things is detectable disinfection residual. So that's why things like ozone and UV aren't effective, aren't acceptable for our final disinfectant. We've got to be able to take care of it. And of course, when they first came out with this in '89, crypto wasn't on their radar. This is the 20th anniversary, so '93. It really made national news, and that's where the interim came in not long after. So after they came up with the surface water treatment rule, they had some big issues. They brought in the interim. That was a pretty quick pass through. They started looking at turbidity as a big issue. And turbidity hides microbes, basically. It shields them and it makes the disinfection less effective. So that was a big issue. No longer could we just have whatever, coming in and going out of the plant. Now we really had to start monitoring it a lot more. And so we're looking at the GUIs. We talked about before about, is it 10,000 or less? This is in the interim. When we get into the long-term one, it actually was for systems fewer than 10,000. So the only ones that have some sort of option for variances would be under 500, okay? And of course, that's with the state. So that's what we're really looking at. Interim started bringing in the standards, and then started to apply to some of the smaller systems too. Long-term 2 really started to look at your source waters, and especially your crypto. So that was a real big, not only what's going out of your plant, but what are you bringing into your plant. So we have to look at how much we need to be able to reduce. And filter backwash recycling rule, big deal. Where's that water coming from? Where are you sending it to? And if you're recycling it, you're concentrating those contaminants and you're putting it back up into your source water. So now you have a greater potential of actually contaminating your water, because if you have a filter breakthrough, now you've got a high concentration. So several different sources of your plant were not supposed to be recycled. And I know that we talked a little bit about it yesterday in Hickson about what they're allowing and what they're not allowing. So your filter backwash off of your sludge, what are considered?
We don't really have that many systems that recycle the backwash. Most of them, send it back to the head of the plant from their sludge lagoons.
Okay. So they're blending that back with their raw?
Yeah, blending it back in.
So they're decanting their sludge. What are they doing with their? Are they have discharge permits for their?
Yeah, they'll have an MPDS permit
Mhm.
for discharge if they can do that. Some systems, depending on the size, can hold it and eventually use all of it.
Oh,
over
just
several
blend
days.
it in on a real small.
Yeah, so they have very little or no discharge back
Okay.
to that. So, yeah, we've I want to say like maybe 2 or 3 here in the Knoxville field office, and then maybe 2 or 3 in the Middle Tennessee area that I'm aware of. So.
Okay. And so, I mean, that's an important component of your overall plant process. And I know, yesterday, Gary with the regulatory down there was talking about that he's really encouraging people not to recycle certain components of it, but now they're concerned about the discharge permits. What does it cost? How much monitoring is it going to take? Who's doing the paperwork? So and those are factors to think about. But
Yeah, there's definitely additional paperwork that you've got to keep up with and maintain and all that. So there's that to consider, but at the same time, depending on how much you can use and all that. And I don't know, we don't have a set percentage, but I think the recommendation is 20%. That's what I've heard. I mean, if you can eventually recycle it, that saves you doing an MPDS permit.
Are you doing anything before you discharge? Because you're discharging.
Yeah, we have to put bio tablets in it to dechlorinate it now, some simply because they lowered our chlorine limits. I mean, we went from like a 1 to 0.04. I mean, so it's hard to make because we don't have a long enough time period where we can leave it there long enough. So that's the cheapest way right now, and it's not very cheap that we found to be able to do it to meet requirements.
Do you have to do anything to deactivate or inactivate the like crypto or something?
Not that I'm aware of. Not on the, I mean, I'm not familiar with the discharge side. But,
Right.
I mean,
You will be.
yeah, eventually. I need to learn it. But
I'm just
I will
wondering
say-
because you're just concentrating it in the stream. Yeah, you're diluting it out to an extent,
Yeah.
but you've concentrated it, and so I'm just wondering if they're doing anything to deactivate it prior to discharge.
Not that I know of. I mean, I think the main thing is just the
Chlorination.
chlorination, and I think maybe you have to do maybe total discharge solids or something like
Yeah,
that.
there's several different tests we have to do and report per
Right.
month and
Yes, ma'am.
stuff.
Yeah, suspended solids and things like that.
Anytime we start it, start the discharge, we have to do a pH and a chlorine residual each time and stuff.
Yeah.
So, I mean, it's getting harder to meet the demands of it. I mean, because they tell you what it can be. And I mean, his might not be the same as mine. They
That's
base
right.
it on the stream.
Yes,
and,
ma'am. Your
I
receivers.
mean, ours is in a running stream that runs out into like I guess a slough, which that stream runs all the time. Which you think that it would dilute it more, but they don't take that into consideration is the volume.
And they
I
look
learned
at,
that real fast.
and they look at the quality of the water in the river, and you can't degrade that quality.
Yeah.
So if you happen to have a really clean river and he's got one that's a lower quality.
Like I said, it was like a 1 for years, and past, I think, a couple of years, I changed it to a 0.04, so I mean, that was a big drop for us.
Yeah. Have y'all considered using, if you're using gas on the chlorine, have you considered using a gaseous dechlorinator?
No,
It
really.
might work a lot faster for you.
So the only thing we've really ever talked about is we don't have sewer in that section. I'm talking about running certain parts. If we could just pump our water off and send it to the sewer,
Right.
like that, and then it'd be the sewer plant's problem.
But that's
you know,
that's a way to.
But then they
to
would
eliminate.
dechlorinate. But right now, it's just
Yeah,
we just
well, the
follow
problem is though,
tablets.
is if you're sending in a chlorinated water into the treatment plant, they're gonna have problems. Cause you're gonna start, depending on the concentration and all, they're gonna have problems because of the microbials. So
I mean,
you can-
it's never really that high, it's just to
Right.
get it below that 0.04, it might be a 0.06, you can't pump it that day, but the tablets take care of the problem.
Right, I just wondered how fast acting they are, if they have to, if they're dissolving and then they're having it, depending on what kind of mixing you have.
Yeah, we just run it through this little, I don't know what it's called, a little blue thing that, you fill the tablets up.
Yes,
And we
ma'am.
take, as soon as we start it, we'll take a sample from that and go up and test it to see, make sure that it is below it, and
Right.
it's just almost instant when it hits. It don't take it completely out, but it'll knock it down below the limit.
Okay.
There's
So
time
then-
it's pulling.
Yeah, so then you need some sort of either a detention capacity or some sort of static mixing or something in it to make sure that you're really getting that contact. Okay.
I
That's
was
interesting.
gonna say that I know of two water systems that actually, they don't send the backwash back to the head of the plant, they actually send it through membrane filtration and then put it into the clear well. And,
Wow.
we had them monitoring quite a bit, actually
Yeah.
doing THM and HA, numbers on that.
Yeah.
And so, one of the systems didn't do it on a regular basis. I mean, they'd be like, of course, they had a huge lagoon to send it to, and they had the capability of sending it to the sewer at the same time.
Yeah.
So they may go 2 or 3 weeks without running it through the membrane system, whereas the other one would pretty much run it daily.
Yeah.
So.
I wonder about membrane integrity. Because if you have concentrated
Yeah.
crypto in there, and if you have a, have a breach in your membrane, well, now you just, if you don't have any kind of filtration, physical filtration afterward.
I can't remember all the tests that we had them doing, but I think TOC was one, THM, HAs, pH, alkalinity. But I don't think we had them doing anything as far as, E. coli or cryptosporidium, anything like that.
Yeah, see, that would be my biggest concern on that is if you had a breach in your membrane,
Yeah.
you're pumping concentrated right into your clear well.
Yeah.
So anyway, it's just interesting when you start looking at who's doing what and how they're trying to do it, and
Yeah.
where are your pitfalls, where you're gonna have your problems. 'Cause that's a big potential. And these guys are like, oh, surface water. If I got electricity, I can get it out of the ground. I can chlorinate it and send it. And that's my background. That's where I came from. San Antonio was the largest city on a sole source, groundwater source in the nation up until early 2001, 2002. And when they started to bring in some surface water, they were basically buying it wholesale from some others. But I mean, you got a well pump that can pump out 20 MGD with almost no drawdown on it. It's just an incredible volume of water. Pull it out, hit it with chlorine, put it in a tank, and push it. It's like, it's beautiful, and you just didn't have to worry about it a lot. So when we started doing some of the surface water components of it, you start to realize all the dance you have to do with the water chemistries and stuff like that. And of course, we were doing just the opposite. We had to take water that most people thought were pretty good, and we had to harden it up. So we did just the opposite of a lime softening process. So it was interesting trying to get it to, try to optimize it. And then the plant had several different modes. So sometimes you're in recharge mode, sometimes you're treating the water. And so it sits for 6 months. Equipment doesn't like to sit. Trying to get back out there and figure out what you did last time. So had a lot of interesting, but I have a great appreciation for surface water treatment. So the backwash filter rule was really important when we start looking at what are we doing with our different waste streams within the plant. How do we protect that water and the integrity of the process? Then they started getting into the disinfection byproducts. One of the main reasons is carcinogens, and then also reproductive issues. And so then we not only started looking at it in the plant and in the distribution system, but then they started going from running annual averages into locational. So it used to be easy if you had a hot spot over here, well, it'd average out pretty good with everything else. Now it's, if this is the hot spot, you gotta deal with your hot spot. And that gets into a lot of your water age. You start looking at your disinfection processes, your TOCs, and how all that's gonna affect it. And then the ones that we're really looking at is trihalomethanes and then the haloacetics.
I mean, it's interesting to see that from Middle Tennessee to East Tennessee. In Middle Tennessee, we have a lot more problems with HAs. And over here in East Tennessee, I mean, it's very rare that we see that problem. The problem's more with THMs. So it's interesting to see that different water chemistry and the issues that are.
So then you wonder what's in the water that's forming those specific components.
Exactly. Because I mean, whenever stage 1 first started out in Middle Tennessee, HAs didn't seem like it was that big of an issue. It was THMs. Well, when the systems started to get more aggressive on their flushing and trying to cut down on that water age, THMs were less of a concern. And then all of a sudden, HAs started to rise up to hey, we're starting to see HA problems.
Yeah.
So it's interesting to see how it all turns out, so.
Yeah. Well, it's that was the thing with the Virgin Islands, they're using rain catchment systems, and everybody has cisterns, and even the big businesses, we're talking about hospitals, everybody has, these cisterns. And so I'm thinking surface water, rainwater is, squeaky clean, Well, they're having a lot of disinfection byproducts. I'm like, well, what it is they've got all the trees and stuff, basically tropical jungles around them, and they don't clean out their gutters and stuff. So they're making tea, and with organic tea, and then when they do batch, they put in such a huge amount. You've got localized, high concentration. You don't have any mixing. You don't have any way to regulate it and have a metering system or anything. So yeah, you can see why their DPPs were so high. So it's just interesting to look at the process and if you had some sort of a screens, if you cleaned your gutters, if you did some things like that, if you batch chlorinated or continual rather than just batching, you could minimize that. Have some mixing, even a diffuser system off of a septic system, something to put some oxygen in there, get some mixing going on, could make a big difference for you. So we did some technical site visits, and it was interesting to see the dynamics. Most of their access points are actually inside of the buildings, and I learned a lot on that trip. Learned a lot about what not to do, or where not to drink. Talk about unfiltered sources, and I mentioned yesterday that that's just really not something that y'all deal with much here. But if you're on an unfiltered surface water source, then you have certain parameters. You got to measure your source water every 4 hours. Can't exceed 5 NTUs. Really, I doubt that there's anybody doing that. Almost everybody off the surface is treating.
Yeah, that's one of the requirements. I want to say there's maybe one, and it may be up in Johnson City, I think, but I'm not 100% sure.
So I'll highlight this for them. But yeah, that's it. Bless you. That's just the thing that very, very few are going to have that. I guess maybe if you're in making cores or something up in the Rocky Mountains where you got crystal clear water coming down, then that would be an opportunity for you. But otherwise, everybody's got some sort of a treatment. So there's just some parameters based on what your source water is, looking at your fecal coliforms, how much you can actually have in there, how frequently you have to test. When you get into filter sources, what we're doing, then we're looking at our conventional. Are y'all using dual media on your filters, anthracite and sand? So we talked about the combined or the individual. How many filters do y'all have?
6 total.
You have 6 total. Okay. You always running all 6 of them, or?
Usually we've got what we call old side and new side, just the original plant and another. So 2 of them's either running and 4 of them. So if we shut 4 down, we're shutting one whole side down.
Oh,
2.
okay.
But most of the time we start out every day running all 6 of them. But depending on how full we get, then we might shut one side down, which is usually the 2 side.
Okay.
2 filters.
Yeah, we were going through some operational conversations a while back, and there was a small system. They had, I think, about 4 or 5 filters, and we asked them, well, do you, after you do a backwash, do you keep something offline for a while? And no, we always put it right back on. Well, what's your pumping volume and stuff? Well, they didn't need all of them running, but it's just, that's the way we've always done it. We're always going to have all our filters on. But if you have something on standby, if you have the operational ability to have that, where I only need 5, you start looking at the volume that you have coming through the plant and your flow rates and stuff, then you have that, in case you have an issue, you have that availability of switching over real quick. So it just depends on your plant and stuff. But it's interesting to see how people operate. A lot of times it's like, well, that's how they did it before me. It's like, well, have you evaluated it? Is it effective? Is it efficient? Is it right? Is it the best? So we're looking at our combined, and then we're looking at our individual also. Combined filter, got to be less than 0.3 NTUs 95% of the time. Y'all have online continuous monitoring for your filters? For your filters?
With the turbidity?
Yes, ma'am. And then you have one for combined also, or I know a lot of people are getting into particle counters now.
We're working on that. We've got part of it. We're still waiting on another part to get here. It's ordered.
So are you pulling samples and running them through a benchtop?
Mm-hmm.
Yeah, we made a change to our regulations back in 2008, I think, and kind of reversed it to say, because originally it was like you grab sample every 4 hours. And then we reversed it to say, you've got to continuously monitor, however, we can approve you to do grab sampling, and all that. So we've got a few systems like Rockwood, who does grab samples, and then they've also got, I think they're using the highest turbometer on their individual, as combined filter effluent for the old side. It's the old side, right? The old side. So, yeah, we've made a change in our regulations. It's kind of different from EPA's.
Interesting. Yeah. And a lot of them, I know that a lot of plants are going to the, I don't know if you've seen the particle counters and stuff that they're moving toward.
Yeah.
A little less calibration issues and all, but still gotta have cows on them. But, okay. So that's why when I tell people, if you're gonna go test for a license, listen to them, and I'll tell you what EPA says, but that's gonna be on the test. Y'all are going with ABC now, right?
Yeah.
I know y'all were talking earlier, Robert was mentioning about the exams being hard.
Yeah.
And especially if you're pulling from a lot of sources.
We just changed it for this past year, and the pass rates were really low. I think overall it's 33%. Was it 55% or something like that on the old test?
I think it's at 107 people or something took it and repassed.
Yeah.
That's what I heard too. I heard it.
That's what they're saying in the TEEX.
That's 3% less.
Yeah.
Well, I think that's 33% overall of wastewater and water pass rate. I think there's a little bit more people that passed on the water side than there were on the wastewater side. So, is Texas?
Texas is stiff. Texas is the third hardest in the nation for their licensing, and they run all their own programs in-house, so they build their own tests and all. California, Florida, and Texas are the three hardest in the nation. California is like, it's crazy there. As a Class A operator, if I was to go out there, I could have like the second to the highest license. I would still have to go, you have to go in front of a review board, do orals to get a 5.
They don't recognize the Tennessee certificate, do they?
I don't even think they have let you use the formula book or anything, do they, on their test or anything?
No, I think you have to know all your
You have to
formulas.
know it all.
Wow.
Yeah, but Texas is pretty tough to be an A operator. You have to have 8 years of experience. You can do substitution with education, but you still have to have a certain amount of hands-on. And they're talking about changing the Texas test also to where it's it'll be all multiple choice, but there can be multiple answers within it. So if there's 2 or 3 right answers, you have to know to choose those 2 or 3 right answers. And the pass rates, we had some paperwork not too long ago on it, but on the A level side, it's about 18% pass rate.
Wow.
They're stiff, so not real easy tests. But you also want, if you're going to be at that level, you want them to be a competent. And I understand it's that dynamics. You want to run people away. You want to have integrity in the licensing process. So it's a kind of a balance you got to strike in there somewhere. Because you can have it so tough that nobody ever passes. And that's not helpful.
It's good for a licensed operator. I mean, but if you're not, then it's gonna hurt a utility.
And it should drive the value of the operator up.
It should.
Yeah, it
And
should drop it now. In Tennessee, I don't know if it will.
Well,
Justify some way it can pay,
yeah.
but that's
And at some point the market, and it doesn't always help the individuals that have been in the business a long time. A lot of times it's the individuals that are coming in now. The standards that y'all are setting, somebody else is going to reap the benefit of it. But when you have less people able to pass the exam because they're more stringent, now you have a higher demand on the marketplace. You can command more. So there's a cause and effect to it. But sometimes it takes a good while for that to actually show. And ultimately, there's some businesses that just don't pay as well as others. We know how it is with the state, municipals.
Yeah.
The private industry can do a whole lot more.
A lot of time, it becomes like Rockwood, a small system like that, becomes a training ground for the larger systems.
Right.
So,
Yep. Yeah. So that has a lot to do with it when you start looking at the overall dynamics. So, all right, combined effluent. So can't have more than 1 NTU. Got to do it every 4 hours that we're in operation. And we start looking at our, saying there's a little provision there for 500 people or less, then you can, with the state approval, you can go down to just once per day. I don't know if anybody's treating that small amount of water,
We,
you know, off of a surface water source.
what we've probably got some, groundwater into the direct influence.
Okay, some
But I
buoys.
mean, yeah, surface water, I don't think we've got anybody that's
Yeah,
small.
that would be very difficult to
I
operate.
mean, usually if it's that small, they've got true groundwater source,
Yeah.
so.
Yeah, well, you got a couple of 55-gallon buckets out there with
Yeah.
barrels with some sand and stuff in it, you're running it through. Yeah, it doesn't make sense to have that small of a population trying to use a surface water source.
Yeah.
Unless there's just nothing else available.
Yeah, and I mean, we're blessed with having good water. And
Right.
all that, so it's, if they're doing the once a day, then they're using the groundwater into the direct influence, source, not a true source.
Yeah, not a true surface.
Surface water source.
Very good. When we're looking at our individual filters, we're monitoring constantly. We've got to actually have a recording every 15 minutes. So do you have a recording device?
Mhm.
Okay, so you have some sort of a, is it standalone there? Because it's not integrated into a SCADA system for you.
No,
right?
it's just, each filter's got their own turbidity chart.
Okay, so you got the wheel
Yeah,
chart.
just do it though.
Hey, it works.
Old
It
shorts.
works. I mean, it's.
That's what Eric likes. Makes his
it's-
job easier.
Yeah, I mean, you know, it's, if you've got, you use what you have and then you make it work. And it's effective. It might not be the latest and greatest, but you know, I mean, it's tried and true stuff, so.
It meets the requirement.
It does. So, yeah, make sure you got fresh ink in there. And you're good to go. So we do have to calibrate. Do y'all have instrument techs that are able to do your calibrations as well?
They come in every,
Oh,
3
okay.
months.
So it's contracted?
Yeah.
Okay, very good. So you do have to, and like everything, if you wanna build an O&M program, go look at your manufacturer's recommendations, that's real straightforward. If you do have a meter that fails, we talked about this on the exam, you gotta start doing your grabs every 4 hours. You got 5 days to get it back in business, 5 working days, not calendar days. So it gives you a little bit of time to get something ordered or sent off.
Actually, we go with calendar days.
Do you now?
Yeah.
Okay, so you actually give them a little bit
Yeah,
extra.
because I mean, it's,
Oh, no, that gives them less
weekend.
time.
Yeah, I mean, because I mean, on the weekends and stuff like that, we consider that
Yeah.
part of the time the plant's operating, so it's 5 days.
Interesting. Okay. So the state can be more stringent, so overnight it.
That or contact another water system and
Yeah.
have a spare or something like that.
Yeah.
I've had to do that a couple of times.
Sure. Yeah.
Shut it down long enough to get from the.
Top off the tanks and run. Alright. Yeah, get you to start closing valves out there so people use the less water. Oh, sorry.
Good luck on that.
And then anytime you do have these issues, you gotta submit to the regulatory authority. And it's important to include them and stuff. If you have turbidity issues over 1 and 2 consecutive 15-minute measurements, then you're gonna have to start doing your filter profiles.
We've actually got that at 0.5
Okay,
instead of 1, so,
excellent. I mean, it's stringent, more stringent is, it's better for your consumer. Ultimately, that's what we're trying to do, is make it the best that we can, so. You got a 7-day window on that one also?
yeah, I believe so.
Okay, do your profile. Do y'all go out and help them do profiles on the small system?
Well, I mean, we've not seen a lot. I mean, usually whenever there's a reading like that, there's an obvious reason for it.
Yeah.
And so they don't have to do a filter profile because they have an obvious reason for it.
Yeah, mud balling or something like that, right?
Yeah, I mean, you know, coagulant pump goes out.
Yeah.
They didn't catch it in time. You know, so I mean, I think since it's been implemented, I've seen maybe 1 or 2 filter profiles, but I mean, we don't go out there and do it for them. I mean, we
Right.
tell them what we'd like to see. I mean, essentially, it's just your turbidity chart, you know, from backwash to backwash, while another one's, and you know, here's where another filter's in backwash and stuff like that.
Yeah.
So I think maybe I've seen 1 or 2 in all the filter exceeds reports. The rest of them have just been obvious reasons why.
Okay.
There's been a.
So as long as you can justify it, then.
Yeah, it's, if they have an obvious reason for it, then they don't have to do the filter profile. But if they can't figure out why this happened,
Yeah.
then they have to do the filter profile and submit that to us within 7 days.
Okay. Excellent. Talking about systems less than 10,000, they won't have to do the profile, so then that figures into some of y'all also. If you have your turbidity, and here's your 0.5, so y'all are requiring that as a more stringent component of it. We on our filter performance report, it starts out at 0.5 is the first question. Did you have Okay.
any readings above 0.5 and 2 consecutive readings? And then it goes up from there. Did you have
Okay.
anything with the one and 2? I didn't read ahead, but I
That's
didn't see
okay,
that.
no
so.
problem. Alrighty, let's see where we're at here. So we're still talking about if you're exceeding the 1, and if you have that occurring in consecutive months, 3 consecutive months, now you gotta start doing filter assessments and all, because you got a bigger problem than, just an easy solution.
Yeah.
If you do only have 2 filters, you gotta do both of them. If it's greater than 2, you got real issues in 2 months, then you're also gonna have to do a comprehensive performance evaluation, CPE. And, the state's really gonna get involved. We're gonna look at a lot of different components, so you don't want that. Have something on backup, make sure you're dosing right on the front end. So we're just looking at the CPEs. I don't know if anybody that's using diatomaceous earth, sand, or just
I don't
straight
know if
sand,
anybody-
slow sand.
Yeah, pretty much it's mixed media
Yeah,
on most of them.
so it's not real applicable, but there are guidelines if somebody is happening to use that. I joked earlier about the 55s with sand thrown in it, and that would be those people. But, it actually works if you're out in the middle of nowhere. You can filter yourself if you know what you're doing. And then we start looking at alternative filtration. If you're starting to have issues with some of the things that you can work on. If you're measured every 4 hours, then the state's going to help you set it up. You got to demonstrate what the technology is. You got to make sure you're less than 1. It can never exceed a 5, and they get then again some for the real small, the 500 or fewer persons and all. When we talk about our profiling and benchmarking, talk about our significant changes. What are our significant changes? We're looking at the types of disinfection and the application points. Those are the 2 big ones. So, are you do it on a regular basis, disinfection profiles? Is it you establish one and that's basically free slam?
We look at it more of a CT calculation type. Some systems do CT calculations daily. We've allowed that you can do a worst case CT calculation, and if any of those parameters are exceeded, you do the CT calculation for that day.
Okay.
But no, we don't have systems doing a disinfection profile
Yeah, it's
all the time.
not regular. Okay, yeah. And Bonnie's like, she doesn't want any part of that. There's enough
We're
paperwork.
record it, but I don't do it.
enough paperwork on the desk.
Uh-huh.
Good. So when we look at our types of changes, again, the main thing is the change or the application point, because that's going to affect your CT time overall. That's going to be a big component of it. Then it talks about if you are doing a disinfection profile, you got to do daily measurements, and you look at pH, residual temperature, and then you need to collect those during your peak flow, because that's going to be your highest demand or the shortest transit time into your facility. And then it gets into, again, all the legal fun stuff. Then your average inactivation value is going to be for the 12 months, and you're looking at it, what's the lowest value that you have, what's the lowest value you reach, and that's going to be your benchmark. And then for crypto, obviously our goal is 0, but they do want a 2-log removal if you're under the surface water treatment rule. And nobody's using the slower diatomaceous earth. Interim, that was looking at, especially like Giardia was a big issue for them. So again, they're looking at the residual of 0.2. Some of this is redundant, it's legal, so it's, they repeat it multiple times. Combined filters, so 0.3 of 95% of your samples, can't be greater than 1, or you gotta report it. Especially after backwashes, can't have 2 exceedances in 4 hours of 0.5, so that's a big deal. If you got a filter that's having a problem, take it out of service. That's why it's good to have something on standby. Pull it out of service, you gotta backwash it again. And it's also helps if after you backwash it and you do your filter to waste for it, if you can let it sit for a while, it'll help compact it instead of putting it right back into service, because it's the greatest chance for you to have an exceedance unless you have a breakthrough on your filter. So, and that's, if you're able to cycle your filters on and off like that and have something in standby, then that filter's gonna typically be better suited for your needs. What are y'all getting on runtime on your filters?
We usually just go by our loss ahead. There's times, we'll get 6 or 7 days, and then there's times you get 2 and 3 days.
Yeah.
We usually
That's
just go
your,
by our
that's your,
loss ahead.
yeah. And see, the way we were treating, we really didn't have a big issue of loss ahead or turbidity issues, so it was runtime. We just set up runtime like 96 hours, and that's when we would do our backwashes and stuff on it. But, so if you're getting enough in there that your differentials are changing. Yeah, different times of the year, you figured out that different times of the year, your water quality is a lot different.
Yep.
What do y'all have the most issues with? Fall, springtime?
Usually it's fall,
Yeah.
that's when we start getting a lot of more air binding and stuff like that in our filters, so.
Yep. Good to know your plan, good to know your source. Very cool. So it's just some of the repeats. Our individual filters, we got to monitor every 15, continuous, and then report. These are for the NTNCs. Y'all are actually considered, are they NTNC?
Yeah, but they're true groundwater.
Okay, so they don't have to be put, but as a source, though, they're considered, right, because they're not, they fall under the,
They're not a UNG system, but they fall under the groundwater group.
Right.
Instead of the surface water treatment group.
yes, sir. But, yeah, I was just wondering, because is it actually a transient, if it's a,
Yeah, it's considered a transient,
okay,
water system.
okay. So, uncovered finished storage, water storage. Luckily, almost nobody has that anymore,
Pretty much outlawed.
Yeah, it's, they're supposedly, we were talking about that in, Arizona, up in Seattle, there's supposed to be a real big one, like a 50 million gallon, basin that they had built years ago, and they haven't covered it yet because of the costs. And that's like their only major source of storage, so they've got some sort of a little exemption or something, but, yeah, you don't wanna run around seeing birds hanging over the side of your clear well or your ground storage tank or something like that. Record keeping, gotta keep stuff for 3 years for your filters, and then sanitary surveys, 3 years for the communities, 5 for the non-communities, and then if you're an outstanding performer, then you can go to 5 years.
We've actually, on the sanitary surveys, we have them for 10 years.
Do you know? Okay,
Yeah.
interesting.
The individual, the charts for the individual filters and all that is 3 years, but the sanitary surveys and.
Is that for everybody across the board, 10 years?
Everybody, yeah.
Oh, okay. Well, that's a benefit, for those having to do it, and those having to go out and assist them. So when you look at your sanitary survey, what do we need to have in there? We need to look at our source, how's it being protected, what's in it, how are we treating it, what's going on out in our distribution system, where are we storing our water, what shape of the tank's in, that's a big aspect of it. How are we keeping up with our pumps and motors and all, where the contaminants are possibly coming in from. What are we doing with our data? How are we storing it? How are we, providing it? And then management and operations is a big component of it. And then operator compliance. We start looking at, who's certified, who's out there doing, what they're supposed to be doing. And then, of course, your review of your disinfection profiles. Deficiencies, gotta be communicated within 45 days. LT1, for the little small systems, they don't have to do the profiles, but they do have to do the benchmarking. You gotta look at your crypto, you gotta make sure it's covered, your reservoirs, and then nobody's using unfiltered water, so. Monitoring for crypto, you had a 2-year monitoring period, is that correct? When you first, when it was enacted, LT2?
Yeah, I think if you're monitoring for crypto, and then if you're doing the COLA, I think it was like for 12 months.
Okay.
Yeah,
Was it every other
If
week
you-
or every week for 12?
Every 2 weeks.
Yeah.
Every 2 weeks for?
If you was below a, what,
10,000.
10, yeah, then you didn't have to, yeah.
And y'all were able to do it in-house?
Mhm.
That's
We
pretty
actually did ours and did one of our systems close to us.
Uh-huh.
We run all their tests for them, so.
Revenue generating?
Do what?
Is it revenue generating for you?
No. It was pro bono, I guess.
Uh-oh. Well, that's a good Samaritan in the community, but it's always interesting because there's obviously cost associated.
Mhm.
So, and that's one of the things, you look at your system and you figure out where's the money maker, where's the money spender, and the lab's always a spender. So if you can generate some revenue, everybody's, especially management's happy about that. There could be some issues taking on other people's work, but there could also be some benefits from it. So we talk about the small systems using E. coli. We talk about bin classification. I guess y'all have bin 1. Is that correct?
Yeah, most of our systems are bin 1. I think across the state we may have less than 10
Good.
that across the state that were maybe in bin 2.
Yeah. Well, then that speaks well of your source water protection.
Yeah.
That's a huge component of it. Knowing what's located where, keep the feedlots right off of the, the main water course and things like that. That's a big issue. So if y'all are in bin 1, then y'all are on the right track. You don't have a whole lot of extra stuff you need to do about it. If you are high, then of course you might have to look into your source water protection. Somebody was mentioning the other day about as you drive and you top a hill, what sign do you see? You're entering a watershed. That's real important for people to understand the dynamics, how big some of the watersheds are, and what's influencing them. So I find that interesting that that's something that y'all are. And I guess I don't know how many years y'all have had that in place for identifying different watersheds.
I think about the last 5 years.
See, but that's as a public, getting people to think about those things are real important. Getting them to be aware of what's going on. Quit dumping the oil out on the grass and and stuff like that, or down by the little the drainage ditch. Simple things like that go a long way in helping your systems. So then there are some other options you can look at: filtration, other treatment. Main thing again we talked about with our disinfection byproducts is the carcinogens. So our TTHMs, the MCL is a 0.08 or 8 micrograms per liter. If you're a small system, y'all are just doing what? Are y'all still doing 1 per quarter on your total
We
trihalose?
got 4 sample sites on THMs and acids,
Okay.
quarter.
Okay. Good. And then, like I say, here it's the running annual average. If you're a real small system, less than 500, you got to do it during the warmest month. Groundwater systems, they're just doing 1 per year. They're not even. Y'all have to do.
Non-communities now. I think if you're non-transient.
NTNC. Yeah, schools and stuff. They have to do their primaries and secondaries
Yeah,
once a year.
that's once a year, and
Yeah.
I think most of ours are reduced down to once every 3 years now. So.
Yeah. As long as you have that history of that you can demonstrate, there's no major changes in the watershed. That's beneficial for your people.
It is.
It's a dual-edged sword.
Yeah, I mean, also the 3 years comes up and you've got a call to, hey, you've got a sample sometime in the this month, and, oh yeah, thanks for calling, it's,
Yeah.
we forgot about it. so.
Out of sight, out of mind. Yeah. Well, and if you do wind up with a problem, now you gotta try to figure out how long has it actually been going on, what's changed in the area, you know, what's contributing to it. Halo Acetics is a 0.06 for your MCL. Y'all aren't having any real issues with bromates and stuff, right? Nobody's using chlorine dioxide or very little, so you don't have any chlorides or chlorate issues. One of the big things is with chlorine dioxide, if you 0.8 is pushing it, hit a 1, now you're going to be sampling every day and you have a lot of issues going on. So if you are using chlorine dioxide, you got to keep a real close eye on your residuals. Free chlorine, we've already talked about. MRDL is 4. Looking at a running annual average, you got some people that they're a roller coaster, so they're really high and they're really low. And if you can get that continual feed, some regular feedback monitoring going on, you can even that out and have a much nicer disinfection profile over time. Chloramines is the same as chlorine on the 4.0. They're looking at a annual average, and then you got to sample that just like you would your chlorine out in the system. Wherever you're pulling your back tees, you got to do your residuals there. This is a little bit about the chlorine dioxide. If you do exceed it, you're going to be doing a lot of testing. So, and then talking a little bit about the TOCs, depending on what your source water is. You said your Bonnie, y'all are looking at a 1. So, and if your alkalinity, I imagine your alkalinity is under 60.
No, we have,
You think it's higher than that?
yeah, sometimes it gets to about 80 or so,
Okay.
like that, but usually if it starts getting above 80, then we can tell it, because we'll start having problems, you
Yeah.
know, but, it's usually somewhere between 70 and 80.
Yeah. Well, and the more stable the water, the higher the alkalinity, the less reduction that you have to have because you have a more stable water. So, and you're looking into anywhere from 25 to 35%, but that's not a bad range to be in. Then you can do jar testing. Step 2 is jar testing, if that's something that you're looking at. Point of diminishing returns, figuring out just with coagulant, how much you're able to add, how much you're able to precipitate out, and based on alkalinity. So those are some of the things that are an option if y'all aren't having issues with DPBs, and that's a good place to be. Your source water, if y'all are running real low source water, TOCs, that's helpful. I don't know of anybody that's doing the SUVA, not around here anyway.
Not on a regular basis, and if we have a system that's having, all of a sudden having a DHMHA problem,
Yeah.
it's maybe one of the things we ask them to maybe look into is to run an ad to see if
Right.
maybe it's the TOCs, that's, hurting them or something like that.
Right.
But, we don't have anybody doing it on a regular basis.
Yeah, so, and that is an option on your well water if you do have an issue. You are able to look into that as a potential alternative. One of the things interesting about the disinfection byproducts, how many people are exposed? 260 million people are exposed to disinfection byproducts, so it is a big deal. Obviously, we're not looking at acute issues like you do with microbials, but it's that long-term, that chronic potential that we really have to take into consideration, and especially our compromised populations, our children, our elderly, things like that. We really have to be more concerned about them. Initial distribution system evaluations. So when we start looking at our disinfection byproducts, got to figure out where our hotspots are in our system, and then we got to monitor those regularly. So how many did y'all pull in y'all's system when you first started to evaluate it? You know?
Probably about 8.
Yeah, we had, I think, 8 different sample sites.
Okay.
We went to.
And then you had to build a profile over them for a period of time and determine which ones you were going to use. And what do you say you're pulling how many now?
We're still pulling forward. We start, I think it's the last quarter of this month, or this year that we go to the.
Yeah, pretty much all
to the
of
test.
the rest of our systems will start stage 2 monitoring at the 4th quarter of this year.
Okay.
So that's got a lot of them concerned because they are going from that quarterly average, overall average to a locational running angle average where, hey, I've got to meet it at each individual site now.
Yep.
So,
Just the same for.
Yeah, so if you do have areas that if you have a hot spot out there or something like that, obviously this is gonna put the spotlight on it. So then you have to start looking at what can you do to minimize that in your system? And some of it's flushing program, some of it is your disinfection location, your techniques. What are you doing? If you don't have high TLCs, you don't have any problems with disinfection byproducts, do you?
No, I mean, we've had at times high THMs and stuff, but
Yeah.
not none that we've had a violation with or
Right.
anything.
Well, and if you got low TLC coming in, then that helps obviously a lot.
Mhm.
So,
Yeah, we actually went from monthly to quarterly on the TOCs.
Good.
No, that's on TOC, yeah, Rodney and them installed some flushing hydrants too out in our system to help,
yep.
so that automatically.
Yeah, auto flushing hydrants are real important. Yeah, 'cause it's a lot of man hours when you're out there having to flush them on a regular basis. And if you know where your hot spots are, if you can utilize that water somehow, that's great. If not, you still gotta get it out of your system. And then sometimes it's just the dynamics of your system. You go and put in a main because you're expecting growth, but growth isn't coming for another 5 to 8 years, something like that. So you've got water that's not moving like you would like it to. So you gotta deal with it. So yeah, the big issue is the locational running annual average. I hear that a lot from people. That's their biggest concern, and it's understandable because you have a population or a subpopulation of your water users that are having high TTHMs or something like that. You've got to be able to assist them. You know, it might look great across the city, but it's not appropriate. So, and then we start looking at our if we start having exceedance, we're going to have to increase our monitoring. And that's one of the ways that they consider that an early warning. And then you're going to have to actually go in and do a review of your operational system, what's going on with it. You got to submit a report, then you got to figure out how you're going to mitigate it. And that's just what we were talking about. You got to increase your flushing, you got to change your disinfection profiles in your system. How are you going to, in your treatment plant, you're going to actually come out with a lower residual and then boost it somewhere else. What are you going to do to change it? So.
We've got a lot of systems looking at tank mixing systems to try and get the water to mix better. So.
That's a neat idea. To be able to they have little mixers that actually sit in the tank, so you're not stratifying your water in your tank. Again, just some of another disinfection point. If you can come out with a 1-2 versus a 2-5 out of your plant, and you can come out with that, and then somewhere else down the line you can boost it again. Well, then you don't have nearly as much free chlorine in there forming your disinfection byproducts. And valving, valving is a huge issue. When you start looking at your dynamics of your plant, of your distribution system, where are your dead spots? How can you work your valving to actually, that's master planning, to get some of that water to move out of areas that you don't want it sitting for a long time? Because you can be short circuiting. You got a fast track here, the highway, and now you got this over here that's the backcountry road. Nobody's using the water out there that's sitting.
That's what we had to do on the new subdivision that we done. We only had 1 or 2 houses, and we had to turn the water on over there, and we had to flush it, 3 times a month just to keep water up. So I ended up valving the main line down in Low Point, make it go up and run in front of our house and come back and feed through. And it keeps the chlorine up because it's moving through that area.
Yep, that's knowing your system. And that's somebody with 20 years of experience, 19 years. But I mean, that's important. It really is. We talked about that with individuals getting ready to retire and stuff. Mentoring is so important. Building, because once again, when you walk out the door, if you haven't established that knowledge that you have in some sort of computer database and other individuals, that knowledge walks off, and that's tough. You know, at least if you retire, people can plan ahead. But if you move to another position, another organization or something, that's really hard. So, yeah, I have a lot of admiration for people that have been in the system for a long time. They go out and walk the system and tell you, yeah, I remember when they put in this valve and when they, you know, how it affected over here. That's, you know.